Well, hello. Sam Owens here, and I've got an important message for new Slingshot owners and veteran Slingshot owners. Uh, there's a there's a lot of interest in the new modifications that are coming out for turn signal system modifications, like the switchback mods, where you can add to the front fender area a strip of LEDs that will display running lights while you're running. And also, when you activate your turn signal, will make the running lights go dark and produce a amber flashlight for the turn signals. There's nothing wrong with these new accessories, but there's an issue with the Slingshot, the Polaris Slingshot flasher module. It has a limiter inside the design of the flasher module that restricts current limits from a high end or a low end. It has to fit within a range. And I feel like that from what I've witnessed through posts on various forums for the Slingshot owners, that a lot of people are showing signs of problems, various problems. And it usually they enter the signal flasher system. I want to explain the flasher system and how new products, though there's no fault, they're totally designed. There's nothing wrong. I'm not downing this. The problem is we're adding these accessories to a system that was not designed to fully encompass all of the current limitations that the flasher can handle. These products are, in my opinion, causing the flasher to exceed the current limit design that the flasher was designed to handle. I hate to make this so detailed, but I want to fully explain it because I know a lot of people that own Slingshots have absolutely no idea of current Ohm's law or any of this. I understand it, and I'm trying to explain it in terms that you will understand. Okay? Uh, Pardon me. I'm live, and sometimes my nose itches. Okay. Now, let me begin by trying to go over here. Golly, I can't. They've changed my YouTube format where I cannot display what I was trying to show. So I'm just going to have to go through an explanation. Let me explain the flasher module in the Polaris Slingshot. Now, its job is to send signals to your front and rear turn signal LED lights. There's a left and a right in the front, a left and a right in the back, and the module, the flasher module, has two sections, left and right, that it will, when activated by the turn signal lever, if you operate it to the left side by pushing down, a set of contacts are operated inside that housing of your steering column. A signal is sent down to pin number 2 of the flasher module, and when the flasher module receives this, it sends a signal out to the corresponding LEDs left or right for both front and rear. It also does a current check. This is the critical part. It determines how much current is flowing in the circuit when it activates. So you're going to get one flash. In that flash, the module is like a computer. It determines, has it exceeded the limits or not? As simple as that. Now, under normal conditions, for folks that never have added anything to the turn signals system, it probably will always read in the correct term, unless you have a burnout bulb. Now, if that's the case, you're going to exceed the lower limit of current. Not enough current is flowing. It knows how much current is supposed to flow when both front and rear LEDs are lit. This is very important for safety reasons. If you drive along and you don't have one light flashing and you have the rear flashing, let's say the front is out, the rear is not. If you're driving like that and you don't have a check system for the current, then you have no idea that the front is not flashing, and all your indicators are flashing away. Your dash indicator light would be flashing, indicating, hey, I'm turning left and everything is fine. So the people in the safety issues have determined that, hey, this is not acceptable. And I wouldn't want to drive with a system that would allow that. And I don't think you would. So in this safety system, I don't think a lot of people that are designing accessories and what have you have taken this under consideration. Now, what we need, and I'm going to go away from my description a little bit, what we need is a flasher that is more heavy duty, and the lower limits are not a problem, because when you add things to the system, you're going to increase the current. So the lower limits are not a problem at all. So what I've described would happen whether you had the lights on or not, the switchback lights. So we don't have an issue with the lower limits of the safety is there. If one of the light bulbs burn out on one side, you are going to get a steady green light on your dash saying they're not flashing. And you need to inspect them before you drive any further. Okay. Now let's go to the real problem. The real problem is that the Polaris Slingshot flasher module, which is, by the way, mounted where you cannot just go to it and check it, like pull it out or look at the pins or unplug it easily. I have a video that will show you how to gain access to the flasher module, and I'm not going to go any further than that. You go to my YouTube channel, Sam Owens 44, and you look for anything about turn signals, and I have several videos about it. Lost my train of thought there. But what we need to do is when we understand the module a little better in the current requirements, then we know, oh, I know what it was. I'm sorry I lost it. I don't have a script. This is live, and I'm trying to get this out because I know it's important for a lot of people. It's hard getting old. Oh, golly. I wish I could back up and see where I was. And I can't pause. Okay, let me just go to this point. The Slingshot, uh, the Polaris Slingshot flasher module needs to have an additional flasher option for folks that want to add additions. It needs to be able to have a heavy duty range for the higher current limit. Something that will allow these accessories that we want to add, like the switchback device, and will fit right in without any problems. I feel like that the new devices that are being added are exceeding the ranges, or they're right up to the limits. That's why we're having intermittent problems. Sometimes the current is a little higher and not. When you're running your engine, you do have higher voltage. This is going to affect the current a little bit. So I think we're riding right on the edge of this, and this is why it's so hard to determine. I've heard folks, not heard, but I've seen posts where people will be driving along, the signals fail with these external devices added to the system. And when they stop, turn the engine off, crank it back up, everything is working right for maybe 10 or 12 more turns, and then it fails again. So this is an indication right now that we're right at the edge. As a matter of fact, I tried to install some LED turn signal monitors. The monitors are about 6-inch strips of LED that I mounted to the driver's turn signal, or the rear view mirror arm. It's about 6 or 7 inches long, and there's 2 rails there. I mounted a left signal indicator on the left rail and the right on the right rail. And this was to allow me to know that when I activated my left or right turn signal, I could see the flashing light of the LEDs that I installed, because I drive around with my turn signals on, because I don't hear any signal that when you make a 3/4 turn, it doesn't cancel. So this is unsafe. And with these LEDs are very bright, and they give me an indication, and I love them. I think everybody should install them, and I think there should be a product, and you mount them on the left side where they're right in your vision. If I'd have mounted it on the right rear view mirror arm, it would have been too far out of my vision, and I wouldn't have been able to see it. So we need to, well, let me go back. When I install these lights, here's what happened. And that's what got me into describing all of this. I turned my turn signal lever to the left without the engine running. I just was in my garage. I turned it on to the on position and operated it to left. All of my turn signals, front, rear, and my strip on the rear view mirror arm for the left flashed very bright, beautiful. I did the right. Everything worked great. I said, oh my God, this is happy. Well, I said, I need to drive and find out how this works out in the light conditions. It was noon or 9 o'clock or what have you. So I wanted to see how bright it would be in the daylight. So I cranked up the motor, went out, made my first left turn, flashed one time, stopped. Oh my God. So what in the heck is going on? I operated the right side, flashed one time, stopped. Now I understand, after understanding the flasher module, it went through a current check, found out that I'm exceeding the limits. My motor's running, I'm running 13.7 volts. Actually, I was probably right at the borderline, and it pushed it up just enough to get into the fail limit. Turned right around, went back to the garage, and I understand Ohm's law. I understand a lot about electronics. So I determined right away, no question, I have a current problem because I'm installing my LEDs in parallel. When you do that, you're drawing more current through that circuit. And so now the flasher is seeing a lot more current than it would normally. So I said, let me try a resistance in the turn signal LED that I connected to the signal lead. For each side, I put a resistor in series with where my LED positive lead went to the turn signal lead. And this is in series, and so it lowered, a resistor lowers the current. I just clipped alligator clips to it and just to test it out. I didn't actually have a resistor. I had a relay, and I measured the relay coil, and that's what I was using, as the coil as a resistance, because I'm like a MacGyver. I use what I have available. Him and I parallel. He's my hero. So I knew that if I put this relay, the coil in series with the flasher lead, that I would have a resistance of 75 ohms. I put it in both sides, connected it up, cranked up my engine, turned the turn signals on. Voila. I was so happy. My flashers all flashed. My front signals were working. My turn signal monitors were working for both sides with 75 additional ohms. Later, I went out to try and find a 75 ohm. I knew it didn't have to be exactly 75. It could be anywhere from 75 to 200 ohms, and it would work. I arrived at 100 ohms because I found 100 ohm resistor, and I ordered them, and I've now replaced the relays with a 100 ohm resistor, and my lights are all working. One difference about my LED lights over the market switchback lights that are out there is I don't have a driver module. If anybody's ever seen the switchback lights, they come with a driver module, and that's what controls the running lights and the turn signal lights to switch back and forth, and that's why it arrived at switchback. So I ran my LEDs straight, and so my LEDs were drawing too much current. And I added the resistor, and now I have a perfect system that is working flawlessly all the time, not intermittent. So my lowering the resistance, I put it back in the range. We shouldn't have to do this. Polaris or the accessories people, I put it on them. Polaris is not doing anything wrong. Nobody is doing anything wrong. Nobody's looked in to the flasher module and its restriction of current. I can't believe this is happening. If they had, they would have realized that they need to come up with a resistance within their module that would put it within range. I haven't even found where I can find documentation about what the current limits are. Uh, this is copyrighted stuff, the design stuff that they don't reveal. So it's not their problem to accommodate accessory. It's our accessory companies that need to actually give us a heavy duty flasher module to replace the stock module to drive these external devices that they're creating. I know if they see this video and all of our Slingshot owners see this, they are going to demand this, and we need it, and we should get it. We want our lights. I'm not really a big guy on lights. I do have the splitter lights, but I know a lot of people, this is very important to get all these goodies. So our accessory company people need to go to work on this. And I'm making it, I'm kind of whistleblower and showing that we have a gap between accessories and the Slingshot OEM product. And it's their job to meet the requirements of the Slingshot, not the Slingshot to meet theirs. So don't go holler at Polaris. They're doing everything right. They're totally correct. Their flasher module is perfect. So I don't want you to think that they are doing anything wrong. And the accessory people aren't doing anything wrong. They've designed a great product. It's just that they need to figure out how to make it work within the limits of the flasher module. Okay, folks, I can't show some of the things that I wanted to in this video because they've changed YouTube and messed me all up as I was going to be able to show you screenshots, and I can't do it. So with that, I want you to go to slingshotinfo.com, Sam Owens media and information page or section, I think it's called. And you will be able to follow all of my advice, all of my videos, all of my help with the Slingshot, the Polaris Slingshot, and how to do the maintenance, how to work on different things that happen that you need help with. I'm here for you. Mostly I gear all of my stuff for new owners, because we have a lot of super people, smart in all kinds of ways, that are out there to help. I'm just one that is trying to help through video and my way. So I want to see you over there, and I hope this will help you to get ahead of all of this. So if you're gonna, my closing statement is, if at this point we don't have any flasher module that's heavy duty to operate with, so we have to operate within the limits. I've found that if you go and get a 100 ohm to 200 ohm, something like that, if you can find it, and insert it in series with the flasher lead, the left is blue, the right is blue and pink, and it's on pin number 1, you'll probably have your flashers working correctly. So that's my advice, and I hope this will help you. Okay, so long for Sam Owens until the next disaster happens, and I'll be right here for you. Closing.